Well, howdy there, everyone, and welcome to Year 7 Maths in week 4. Now, this is the second lesson for week 4, and we've just come off the live lesson of looking at solving equations. So, some pretty intense algebra. We're actually going to be finishing algebra off by doing some graphing. And to introduce graphing to you, we're going to take you right back to the start of the graphing adventures. And today we're going to look at something which you can see on the screen there is called the Cartesian Plane. So if you've got your book open, this is your heading, the Cartesian Plane. Today's date, which you should be accessing, this is Tuesday the 12th of May. And we're going to go through and introduce to you what the Cartesian plane actually is and how to plot some points on there. Now, as I always say, if you've got the notes pre-printed, you should have that heading already down. But if you are using your book, please take the time to write that down as your heading and pause this video if you need at any stage. So for instance, to get the learning intent down, the learning intent, as I said, is to understand how ordered pairs or coordinates are plotted on a Cartesian plane. And to be able to do that, the success criteria today is to simply identify the parts of the Cartesian plane. We'll show you how to plot those points, and then we'll also talk about the quadrants and how to locate the particular quadrant where that point is plotted. So again, pause the video if you need to write anything from that down, but as per usual, the expectation would be you write the learning intent down. All right, let's do a little bit of a review. So here's a little bit of an algebra question. It's a little bit of problem solving, but it should be fairly straightforward for you by now, hopefully. Ty is 2 times older than his sister. If his sister's age is represented by the letter Y, let's write an algebraic expression to represent Ty's age. So there's our information that we are using there. The first thing we've got to do, obviously, is we've got to represent Ty's age by a letter of the alphabet. So let's actually use the letter T. That makes sense to me, T for Ty. And as you can see over here, I've already told you that Y is going to be Ty's sister's age. So now that we've defined our variables, I'm going to stop, and I'd like you to see if you could come up with an equation that represents Ty's age using these two variables. And then try number 2 here and actually work out how old is Ty if his sister is 10. Do you necessarily need to use the equation? It's a nice little way to practice. So pause the video for a couple of minutes and see if you can come up with the equation and then answer the second part. Okay, how'd we go? So the first bit, as I said, we defined our variables, which is T and Y. And if it says Ty is 2 times older than his sister, that means we multiply his sister's age by 2. And we get Ty's age. So that's why I've come up over here and said 2 times Y. Or remember in algebra, we don't put the multiplication sign in, it's just 2Y. So the second part of that said, how old is Ty if his sister is 10? Hopefully you just substituted Y equals 10 if that's his sister's age. And so Ty is 20 years old, as you can see there. If you didn't quite get there with this question, make sure you pause the video. I'd write the question down and I'd also answer it in your book. If you've got your notes, you should have the question pre-printed. Just write the answer in. What I would like to spend a little bit of time on, though, is what we finished up yesterday, and that's solving equations. So you may remember that when we solve equations, we've got 3 ways that we can solve an equation. We can use our eyes, which is called inspection. We can use a method called backtracking, and we can also use a method that's called the balance method. Now, backtracking and balance, we spend a little bit of time on. They are a little bit more complicated than inspection. And what I would suggest is that you maybe can try each one of these 3 questions here using one of those 3 methods. For instance, part A, you could possibly solve using inspection. Part B, you might want to try backtracking. Part C, you might want to try the balance method, but it's entirely up to you. What I'd like you to do right now is to pause the video for 5 minutes or so. And I'd like you to actually try those questions yourself, please, making sure you write your answer out. And even better, if you could check your answer to make sure that you got it right. So pause the video now and we'll come back and we'll check the answers. Okay, how'd we go? So what I might do is I might work through part A because it's a fairly straightforward one. It's only a 1-step equation. And I might run through these 3 methods. Now, remember I did say about inspection, it's probably not the recommended way to solve these questions, but if you did try inspection with the first one, you might actually be able to see that x equals 15, because 15 minus 5 equals 10. The second and third one here, the backtracking and the balance, I might actually use that example just to demonstrate one more time about backtracking and balance. And remember, backtracking and balance is all about inverse or opposite operations. So you're basically undoing the equations using inverse and opposite operations. Now with backtracking, we actually start by writing down the x minus 5. That's the expression or the equation that we're going to undo. But first of all, we draw an arrow down to look at how it's been constructed. We've started with the letter x, the variable x, and then we have taken away 5 from it, and that's going to give us our answer on the right-hand side, which is 10. Now remember, with the backtracking, I then draw an arrow that goes up, and this is where I undo that expression by doing the opposite operation. So the opposite of taking away 5 is to plus 5. And at this point here, I should be able to get my answer, 10 plus 5 equals 15. So if you did backtracking, that's what it should look like. If you tried the balance method, remember the balance method looks like a set of scales or maybe a seesaw, and you're trying to get both sides of that equation to remain equal. Now, I guess the other thing to remember is when you solve, eventually you're going to get the x all by itself. Remember, you want to isolate that variable and get it all by itself. So our job here is to get rid of or eliminate this take away 5. So to get rid of a take away 5, we do the opposite of taking away 5, which is to plus 5. And remember, with the balance method, what we do to one side, we need to do to the other side. So if I plus 5 on the left, I need to plus 5 on the right. 10 plus 5 again equals 15, and so I think the answer is going to be 15 for the first one. If you used one of those 3 methods and you got 15 for the first one, excellent, well done. If you're not sure about those 3 methods, there they are on the screen. Pause the video and you might like to write down for one more time those methods that you see on the screen, the inspection, the backtracking, and the balance method. Okay, you might also like to now try those methods to try and solve parts B and C if you haven't already done so. I assume you already have, and so I'm going to click on to the next slide where we see the answers. There are the answers for part B, x equals 6. And x equals 4 for part C. If you got all 3 of those right, well done. If you got 2 of them right, that's excellent work. And if you got 1 right, brilliant. If you didn't get any of them right, please make sure that you actually have a go at them again to make sure that you get the answers that you see on the board. And please also make contact with Mr. Freiberg, myself, so that you can maybe get any misunderstandings corrected. Because as we said numerous times, being able to solve equations is a very, very important skill in maths, not only now, but all the way through to year 12. Okay, enough about that. Let's now look at some graphing. And we're going to start by looking at the Cartesian plane. So in your notes, you'll notice that you have the heading Cartesian plane. And if you're using your book, I'd like you right now to put the heading the Cartesian plane. I'm just going to go through these dot points very quickly. The Cartesian plane was invented by a French mathematician called Descartes, and it was a reference system. So it's a grid reference system for locating points on a 2D surface, which we call a plane. Now the Cartesian plane actually has 2 lines drawn at it at right angles, and one of those lines is drawn horizontally and one of those lines is drawn vertically. The point where those lines cross is called the origin, and we define the horizontal line as something which he called the x-axis, and we define the vertical line as something called the y-axis, and you may have already heard of an x and y-axis when you are graphing. These axes actually extend infinitely in both the positive and negative directions, so we can have negative numbers and positive numbers. Now we're going to write whole numbers on our axes, and you'll notice that they actually form a grid that allows any point to be located in reference to the origin. Now this is what it looks like. That's our Cartesian plane. If I just go back to all of those notes, what I'd like you to do is pause the video, and I'd like you to write down those 6 dot points in your book underneath the heading the Cartesian plane. Okay, we should have that done now. If you have the notes, you already have that pre-printed for you. And as I said, if you have your book, please make sure you write those dot points down. Now, if we have a look at this diagram, you might like to quickly reproduce that in your book. I'll just point out the key features. You'll notice that we have the horizontal line, which is called the x-axis, and we have that vertical line, which is called the y-axis. and you'll notice that where those 2 points intersect, that's the origin, as we said right there. You'll also notice that these axes extend infinitely, and you see that little arrow right there. That is telling us that it actually should keep going. It continues all the way up to positive infinity and continues all the way down to negative infinity in the negative direction. Same at the y-axis, going up and going down, both in the positive and negative directions. Now again, like I said, you might like to pause the video briefly and just draw a little picture of that. It is already pre-printed in the notes, so my suggestion might be that to save yourself a little bit of writing and drawing, that you might want to access the notes so that you can see that there for you. All right, let's continue. If we continue looking at the Cartesian plane, the position of any point on that Cartesian plane is described by a pair of numbers. So we put a pair of numbers together, and that's called a coordinate. All right, so the pair of numbers is called the coordinate of that point. Coordinates are always written in brackets, and they always get written as an ordered pair with an x value first and a y value second. Now, that indicates 2 moves away from the origin, and this is where you need to watch and listen very, very carefully. The x-coordinate, which gets written first, tells us how far we've moved either left or right from the origin. So either left or right from the origin. If we take a look at that diagram from just before, if we've moved in the from the origin to the left along the x-axis, you'll notice that we are moving in the negative direction. And if we're moving to the right from the origin, we're moving in the positive direction. So that's why I say here, left is negative and right is positive. Now if I come over and have a look at the y-coordinate shows the movement up or down from the origin. So again, if I go back to my picture here, there's the movement up from the origin in the positive direction and moving down from the origin in the negative direction. And so that's why I've put here the plus and the minus. Now, boys and girls, what I'd like you to do is I'd like you to pause the video again if you're using your book and make sure that you've got all of these dot points, these 3 dot points written down in your book, plus the information about how to form a coordinate, because that's perhaps one of the more important things that you're going to see. Again, if you've got the notes, these are already pre-printed for you, but if you're using your book, pause the video now and write those notes in. Okay, the last little bit of information, I know there's a lot of information here about the Cartesian plane. The last little bit actually says that the 2 axes divide the Cartesian plane up into 4 quadrants. So there's 4 sections, and we call them quadrants. Now each quadrant starts with the first quadrant where both the x and y values, or the x and y coordinates, are positive. So that's called the first quadrant. We then move in an anti-clockwise direction around the graph, and we label the second, third, and fourth quadrants. Now, before you write anything down, just take a look at the slide with me. So here again is my Cartesian plane. It looks a little bit different from the last one, but it's essentially the same one. And you'll notice that I've labeled the first quadrant here in this top right-hand corner. It's where both the x values along here are positive, and both the y values along here are positive. So where both x and y are positive, that's called the first quadrant. If we move around, like I said, in an anti-clockwise direction, you get to the second quadrant. And as you can see here in the second quadrant, now the x values are negative, but the y values are positive. If I move around again in an anti-clockwise direction, now both the x values and the y values of our coordinates are negative. And if I move around one more jump to the fourth quadrant, I'm back to having positive x values, but my y values are negative again. Now what I'd like you to do is, if I jump back to those notes, I'd like you to pause the video and I'd like you to write these 4 dot points down in your book, please. These 4 here. If you've got your notes, then they are already pre-printed, but if you're using your book, pause the video and write those notes down. Okay, after you've written those notes, it might also be worthwhile you drawing the diagram that you see on the board. I'll just get rid of all of my ink there, except maybe just to highlight one thing. Remember, the first quadrant is in the top right-hand corner, and we move in that anti-clockwise direction around the Cartesian plane to the second, to the third, and to the 4th quadrants. So this diagram is really important, and I'd strongly encourage you to take your time to make sure that you get it down accurately. Pause the video and we'll see you on the next slide. Well, that's it for the theory. So let's take a look at some examples now, and let's have a look at actually plotting a couple of points. So this example here is an I do, and what I'm going to do is I'm going to show you how to plot the following points on my Cartesian plane. Here are the points down the bottom here. Now the first one, 2, 3, I've already drawn for you, and let me show you how I came up with that. Now, as I said to you back on a couple of slides, the way that the coordinate comes up with, the way we come up with the coordinate is we're looking at how far we've moved from this point here, the origin. Now, the value that comes first in the coordinate is the x value. So how far we've moved along the x-axis. And you can see in 2, 3, we've moved 2 values in the positive direction along the x-axis. So we've moved to x equals 2, and that's why, or that's where the x equals 2 comes from. Also, the second part of this coordinate, you'll notice we've got a y value of 3. So if I start at the origin again, I move up 3 values in the y direction. Now, if I draw an imaginary line through y equals 3 and I draw an imaginary line through x equals 2, much like playing Battleship, where those 2 points intersect, that's where our coordinate is. And that's why I've drawn 2, 3 up there. 2 across the x direction and 3 up in the y direction gets me to that point there, 2, 3. So, how do I go about drawing the other points? Well, let's take a look at the next one. And the next one is -3, -4. So -3, -4 tells me that I need to move -3 units in the x direction. So if I start at the origin again, that means I'm moving back 3 steps, -1 to -2 to -3, because there's x equals -3. It also tells me I need to move up 4 units in the positive y direction. So there's 1, 2, 3, all the way to the top of the graph, there's +4 in the y direction. So again, where these 2 lines intersect, that's where my coordinate's going to be. And what I would do is I would also write down the value of the coordinate, -3, 4, like that. So that's where -3, 4 is. If I look at the next coordinate, which is -4, -1, again, starting at the origin, this time I come across -4 in the x direction. So there's -1, -2, -3, and there's -4. And this time I actually come down -1 in the y direction. So there was my x value and there was my y value. So again, where these 2 imaginary lines intersect on that particular grid, there's my coordinate, which I'm going to label as -4, -1. So -4 in the x direction, -1 in the y direction. The next coordinate in my list is 0, 0. Now, you might know by now that 0, 0 is actually our starting point. 0, 0 is right there at the origin. So the origin actually has that coordinate 0, 0. So that one's pretty easy. The last 2 might be a little bit tricky. The last 2 says 2, 0. So 2, 0, again, I'm starting at the origin. I look at the x direction of travel first, and I'm going to move 2 units in the positive x direction. So I move 2 units to the right. So 1, 2. 1, 2. It this time says, though, I move no units in the y direction. So I stay put right there. So I put my dot, and that's where 2, 0 is. So I don't move anywhere in the up or down, but I've moved 2 units to the right, and that's why I put my coordinate as 2, 0. The last one is 0, -4. So again, similar sort of idea to the last one. X equals 0, so that means I actually stay put at the origin. I don't move either left or right. But my y value, I go down -4 units, so they jump down -1, -2, -3, -4. That's where 0, -4 is going to be down there. 0, -4. So there are my 6 points on my graph that I've drawn. And if I just tidy that up a little bit, you can see I've got my 6 points on my graph. The second part of this question says state which quadrant they're going to appear in. So remember, this is quadrant number 1, this is quadrant number 2, and this is quadrant number 3, and this is quadrant number 4. And so I can see that my first point here, 2, 3, appears in quadrant 1. I can see the next point, -3, -4, appears in quadrant number 2. -4, -1 appears in quadrant number 3. 0, 0 actually doesn't appear in any quadrant because it's on the line. And well, it could have all 4, but 2, 0, so this one here could be possibly in quadrant 1 or quadrant 2, quadrant 1 or quadrant 4, and this last one down here could be in quadrant 3 or quadrant 4. We actually don't define those as being in a quadrant because they actually sit on the axes. So just be careful, there might be little tricks like that. So as I said there, the important points to note, always move in the horizontal direction or the X direction first and then the vertical direction. And as I say there, that is the law. That is a mathematical law. You always move in the horizontal first. You name the ordered pair or you name the coordinate. And remember, the coordinate of the origin is 0, 0. They are the last, I guess, important little pieces of information, and I'd like you just to pause the video now and make sure that you write those down before we actually now try one together. So pause the video and write those notes down. Okay, let's try one together now. Now this time I'm not actually going to get you to plot the points. I've already plotted them for you, and you can see here over in my diagram, I've got 8 points, I think it is, A to H. And what I'd like you to do is I'd like you to see if you can identify and label the coordinates according to their position and also state the quadrant in which they are located. So on my next slide here, I've actually got some space for me to write the answers down, and you'll actually notice that if you've got the notes, you should have this particular example as you can see on the screen. If you're writing in your book, then I would strongly suggest that you write down this in your book before you actually start answering the questions. If I give you a little bit of a hand to start you off, here is coordinate A up here. Now remember, when I actually label the coordinate, I want to come up with what the X value is first. So starting at the origin, to get to that point A, I've come across 3 in the positive X direction. So I think I'm going to have a 3 for the X part of my coordinate. And if I look at the Y-axis, again starting at the origin, it looks like I've counted up 4 units. So starting at the origin, 1, 2, 3, 4. So I think the coordinate of point A is 3, 4, and I can see that it's in the first quadrant. So what I'd like you to do right now is I'd like you to pause the video, and I'd like you to see if you can answer the remaining of those questions. So identify the coordinates and write down what quadrant they appear in. Pause the video now and we'll come back and we'll check your answers. Okay, how did we go? So first of all, you have to identify where the coordinates are. So I can see coordinate B there. I have travelled neither left nor right in the X direction, so that's when X is going to be 0, but I've gone up 3 units in the positive Y direction. And as for the quadrant, well, it actually doesn't sit in any of those 4 quadrants. It sits on the line. The next one, which is coordinate C. Now, coordinate C is way over here. I've travelled -5 in the X direction, and I've gone up 5 units in the Y direction. And so the coordinates for point C is -5, +5, and it sits in the second quadrant. So remembering that that's quadrant 1, that's quadrant 2, that's quadrant 3, and that one's quadrant 4. For point D is back over here sitting on the X-axis. And so for point D, I've travelled 4 units in the positive X direction, but I haven't travelled up or down. And so my coordinates are 4, 0, and again, it sits on the X-axis. For point E, sitting over here, it sits -2 units across from the origin, and again, I don't move up or down, and so I need to have a y value of 0. For point F, which is sitting way over here, for point F, you can see that I am 5 units in the horizontal direction away from the, 5 units away from the origin. So I put my x value as 5, and my y value, I've gone down 2 units from the origin, and so my y value will be -2, and it sits in the 4th quadrant. For point G, which is sitting here on the y-axis, I haven't gone again left or right, so I have an x value of 0, but I've gone down 1 unit from the origin, and so my y value would be -1, and again it doesn't sit in any quadrant. And the last one, which is point H, I've gone across -3 in the x direction, and I've gone down -4 in the y direction, and it sits in quadrant number 3, as you can see. So check your answers. Let's make sure you actually got them all correct. Could you please carefully check it and make sure that you've got all of those coordinates in the right spot and been able to identify the correct x values and the correct y values. You might like to pause the video briefly while you do that. So that's it for this lesson on introducing you to the Cartesian plane and being able to plot those points. If you're watching this at school, you can now move to your textbook and have a look at Unit 5.7, which is on pages 304 to 307. And I'd like you to complete questions 2 to 9, so 2 all the way through to 9, and then question 12, and then number 14 as an extension question. Now, as I always say, make sure that you scan or take a photo of your work and send to me here at school, or drop it into the Dropbox on the Learning Place. Email is by far the best option though. If you do not have access to a textbook, over the next few slides you'll find all of those questions, and as I always do in the class notes, there is a copy of the textbook exercises, and also there's a separate document just for the textbook exercises also on that eLearn classroom. So there's question 2, essentially the same as the example, writing down where the coordinates or what the coordinates are and which quadrant they sit. In question 3, actually without a graph, can you write down which quadrant they sit, quadrant 1, 2, 3, or 4? So that's all you need to write down for question 3. And then question 4, just writing down which axis they sit. Do they sit on the x-axis, the y-axis, or both? For number 4, it gets a little bit more tricky because you've actually got a bit of a putt-putt, mini golf course there. And the question is write down the ordered pairs, or write down the coordinates of each of those 9 holes. So you're actually identifying and writing down the coordinates. And then question 5 is a little bit of a multiple choice. Read the question carefully and hopefully select the right option. For question 6, again, and question 7, again, we have some multiple choice questions. So again, make sure you read the question carefully, think about your answers and circle the correct option. And then number 8, they start to get a little bit more tricky, but again, number 8 is multiple choice. Read the question carefully, have a good think about it, and then select the correct option. Now, number 9 is where you need a little bit of graph paper. So if you've got some graph paper, that's great. If you've got a blank piece of paper, you need to use a ruler. Maybe make every point on your paper 1 centimeter apart if you don't have graph paper. But question 9 wants you to draw up a set of axes. Draw an x-axis that goes from -9 all the way up to +9, and an x-axis that goes, and a y-axis, that goes from -4 all the way up to +4. Plot those points, and you're actually going to form a picture. There's a couple of little extra complications. You'll notice in the last line it says plot the points with some halves. So do a bit of joining together. And then question 14 is the extension question, and that's an open-ended question there. It says draw that arrow, again draw up a Cartesian plane, draw that arrow on it and give us some coordinates of where you've possibly drawn it. So draw it somewhere on there and write down some coordinates basically. So it's a little bit open-ended, there's multiple solutions. So that's it for this lesson. If we just, and question 12. Yes, I left question 12 out because it's on a big piece, it's on a bigger question. You've actually got a bit of a grid there. So getting into some practical uses perhaps of the Cartesian plane, and that is a little bit of a treasure hunt. So starting at the origin 0, 0, write down the coordinates of where you find those things. So again, just writing down some coordinates. So, yeah, so that's it. So let's go back to the success criteria. Can we identify the parts of the Cartesian plane? Well, I gave you some pretty comprehensive notes around that, and so hopefully you've got all those either written down in your book or in the notes. We also looked at how to plot some points on the Cartesian plane, and we also stated which quadrant they appear. So that's an introduction to graphing, boys and girls, and hopefully we've got a good understanding of how to plot those coordinates. The important thing to remember is that the x value always comes first and the y value always comes second, so your movement along the x-axis always comes before your movement along the y-axis. That's the one important takeaway that I want you to have from today. In the next lesson, we're actually going to start plotting points and starting looking for patterns. And as soon as I say the word patterns, we start looking at algebra, and so you can see that how we're going to start to link this back to what we've done, because we'll be able to identify patterns from graphs and we'll be able to come up with some equations. But more about that in the next lesson. I look forward to receiving all of your work, and I'll talk to you again next time when we start doing some more graphs. Have a great day. Bye.